As part of the GCSE examination, students will be required to answer questions without the use of a calculator. Here are two typical non-calculator type questions on fractions. There are no frills or context to the questions, just a straight up, work out the following. In both questions, 2 marks are given, suggesting that 1 mark will be given for showing working out. This is supported by the instruction on the first page of most examination papers, which state that students must show all working. But it is always wise to show your working out just in case, even if you can work out the question in your head. If your working out is correct, but you make a mistake in the final answer, you can still obtain marks for demonstrating that you understand how to tackle the problem. More cynically, it also demonstrates that you haven't been cheating. Have a look at the 2 parts to this question. Do you know what to do in each case? How would you go about finding the answers? Part A involves adding 2 fractions, whereas Part B involves subtracting 1 fraction from another. Notice that in both cases, the denominators are different. Do you know what to do when adding or subtracting fractions with different denominators? From a teaching-learning perspective, what is interesting when adding and subtracting fractions is that most students are comfortable when dealing with denominators that are the same. For example, if we had the question 2/7 add 3/7, then students are generally fine in adding the numerators, that is the top numbers, together. So the answer in this example is 5/7. But some students come unstuck in such questions when the denominators are different. I'll show you what I mean with this question here. 3/5 add 1/4, or 3/5 add 1/4. We can see that the denominators are different. What some students do, because the denominators are different and they don't know what to do, is to add the numerators together and add the denominators together to get the answer. So in this case, they would add the 3 and the 1 and add the 5 and the 4, giving the answer 4/9. This answer, of course, is wrong. So we end up with an inconsistency in approach to adding fractions. When the denominators are the same, students just add the numerators. But when the denominators are different, some students add both the numerators together and the denominators together, as shown here. The same also applies to subtraction. And this is probably why such questions find their way into examination papers. Do students know what to do with adding and subtracting fractions where the denominators are different? So how do we tackle such a problem? Well, when adding or subtracting fractions, firstly we need the denominators of those fractions to be the same, because we know what to do when the denominators are the same. Once this is achieved, then all we need to do is add or subtract the numerators. Well, let's do that for this question. This is where you'll need to know about equivalent fractions and the multiplication tables. Equivalent fractions are fractions that are the same. So for example, 1/2 is equal to 2/4 is equal to 3/6, 4/8, and so on. All these fractions are the same as 1/2. The relationship between the numerator and the denominator is the same. The numerator is half the denominator, or the denominator is twice the numerator. So how can we create a family of equivalent fractions? Quite simply by multiplying the numerator and the denominator by the same amount, as shown here. Going back to the question, let's create equivalent fractions for 3/5 and 1/4. Starting with 3/5, so multiplying top and bottom by 2, we have 6/10 or 6/10. Multiplying the top and bottom by 3, we have 9/15. And we can continue this for as long as we want. Now let's do the same for a quarter. So we have 2/8, 3/12, and so on. Look at both sets of equivalent fractions. Can you see any fractions with the same denominator? We can see that this fraction here, 12/20, which is an equivalent to 3/5, has the same denominator as 5/20, which is an equivalent to 1/4. So going back to the original question, 3/5 add 1/4, remember we want the denominators to be the same. So let's substitute 12/20 for 3/5 and 5/20 for 1/4. So we now have written the question as 12/20 add 5/20. All we need to do now is add the numerators, as the denominators are the same. And the answer is 17/20. Now, writing out a list of equivalent fractions can be long-winded, but there is nothing wrong in this approach, especially when trying to understand what is going on. However, there is a shortcut for questions such as this. Notice that the common denominator in this question, 20, is 5 multiplied by 4. 5 and 4 are the denominators of the original fractions. To create equivalent fractions, we multiply the numerator and the denominator by the same amount. Looking at 3/5, if we multiply the denominator by 4, we have to multiply the numerator by 4. Notice that the numerator here is 12, which is 3 multiplied by 4. Looking at a quarter, we multiply the denominator by 5, so we multiply the numerator by 5. Notice that the numerator is 5, which is 1 multiplied by 5. So the direct route to rewriting both fractions with the same denominator can be written like so. 3 multiplied by 4 over 5 multiplied by 4, add 1 multiplied by 5 over 4 multiplied by 5, and this of course is 12/20 add 5/20, which is equal to 17/20. And there's your answer, and there's the calculation. So to find a common denominator, we multiply the denominators of the two fractions together, but to create equivalent fractions, we have to multiply the numerator by the same value as we multiply the denominator by, which we can see here. Let's go back to the questions we looked at earlier. We'll tackle part A in the same way. 2/5, or 2/5, add 3/7. So we have another addition, and the denominators are different. We need the denominators to be the same. Let's use the shortcut from the previous example to create two fractions with the same denominator. So we can create a common denominator by multiplying these denominators together. So that's 5 multiplied by 7, which is equal to 35. Now to sort out the numerators. Remember, you have to multiply the numerator and the denominator by the same amount to create an equivalent fraction. So looking at 2/5, I multiplied the 5 by 7 to get 35. So I also have to multiply the numerator, which is 2, by 7. And this is equal to 14. So we have 14/35. Now let's look at 3/7. I multiplied the 7 by 5 to get 35. I therefore need to multiply the numerator, which is 3, by 5 to get the equivalent fraction, the 3/7. And this is equal to 15. So we have the equivalent fraction 15/35. I've now rewritten the question as two fractions with the same denominator. 14/35 add 15/35. and this gives us the answer 29 over 35. And we can check this. If we look at a list of equivalent fractions for 2 over 5 and 3 over 7, we can see 14 over 35 and 15 over 35. Now let's tackle part B in the same way. 11 over 9 or 9/11 subtract 2 over 3 or 2/3. So this time we have a subtraction and the denominators are different. We need the denominators to be the same. Let's use the shortcut to create two fractions with the same denominator. So, we can create a common denominator by multiplying these denominators together. So that's 11 multiplied by 3, which is equal to 33. Now to sort out the numerators. Remember, you have to multiply the numerator and the denominator by the same amount to create an equivalent fraction. So looking at 9/11, I multiplied 11 by 3 to get 33. So I have to multiply the numerator, which is 9, by 3. And this is equal to 27. So an equivalent fraction to 9 over 11 is 27 over 33. Now let's look at 2/3. I multiplied the 3 by 11 to get 33. Therefore, I also need to multiply the numerator, which is 2, by 11. And this is equal to 22. So we have an equivalent fraction for 2/3, which is 22 over 33. I've now rewritten the question as two fractions with the same denominator. 27 over 33 subtract 22 over 33. And this gives us the answer 5 over 33. So that's how we can quickly tackle questions involving adding and subtracting fractions. Notice that in each case, I have shown the working out. And in an examination situation, you will be expected to do the same, as marks will be given. In the next video, I'm going to look briefly at questions involving multiplying and dividing fractions. Thank you for watching.